Tensor operations. Tensor operations are at the heart of TensorFlow, allowing you to perform various computations and transformations on tensors. Understanding tensor operation is crucial for building and training machine learning models with TensorFlow. Let's explore some common tensor operations in detail. Let's go through the arithmetic operations first. Arithmetic operations allows you to perform basic arithmetic calculations on tensors such as addition, subtraction, multiplication, and division. Here is an example where I'm importing TensorFlow STF. You create two tensors, tf.constant 1, 2, and 3, 4, and then tf.constants 5, 6, and 7, 8. A result add is tf.add tensor A and tensor B. A result sub equal to tf.subtract. So this is the subtraction, the previous one was the addition. So subtract tensor A, tensor B. Multiplication tf.multiply, and then division is tf.divide. Give it a go and see how the results show up. Second one is the mathematical functions. TensorFlow provides various mathematical functions that operate element-wise on tensors such as square, square root, exponential, logarithmic, trigonometric functions, etc. Examples are here. For square, you can just say tf dot square tensor A. So tf dot square root is for square root, sqrt. Exponential, you say tf dot exp and pass the tensor. Logarithmic is tf dot math dot log and then give the tensor over there. Reduction operations. Reduction operations aggregate the values of tensors along one or more dimensions, resulting in a tensor with fewer dimensions or a scalar value. Examples of them are, let's say, sum along a particular axis. It says tf.reduce sum tensor A on the axis 1. You can get mean along the axis by saying tf.reduce mean tensor A. You can get maximum value. You can say tf.reduce max tensor A. So this is how you can do reduction operations. Matrix operations. TensorFlow supports various matrix operations such as matrix multiplication, matrix transposition, matrix inversion, etc. For matrix multiplication, you take the two matrices or matrices and say tf.matmul. For transposition, you can say you can say tf.transpose and give the tensor. For matrix inverse, or you require TensorFlow add-ons, which is tf.lingalg.inverse tensor A. Indexing and slicing. You can access specific elements of slices of tensors using indexing and slicing operations. Here is an example. Accessing a specific element, you can just say tensor A 0, 0. You get that element at that particular location. For slicing, you can say tensor A and then say that first element you want to slice, so you can say give that index over there. Next, broadcasting. Broadcasting allows tensors of different shapes to be combined in element-wise operations, with TensorFlow automatically broadcasting the smaller tensor to match the shape of the longer tensor. So how do you do that? You can use broadcasting in arithmetic operations. So by saying, let's say if I create a tensor C equal to tf.constant 1, 2, result broadcast tensor A plus tensor C. Tensor C is the broadcasted to match the shape of tensor A. Tensor operations are essential for manipulating tensors and performing computations in TensorFlow. By mastering tensor operations, you gain the ability to build and customize complex machine learning models, perform data preprocessing, and analyze model outputs effectively. Experimenting with various tensor operations and understanding their behavior is key to becoming proficient in TensorFlow development.